The sun has been used to heat liquids for centuries, ever since a human first left water out in direct sunlight. But it was a Swiss naturalist named Horace de Saussure who designed the first working solar water heater back in the 1760s. Saussure built a shallow wooden box, insulated the inside, then trapped water there. When he covered the box with glass and left it in the sun, he discovered that the water inside heated up to 228 degrees Fahrenheit, 16 degrees above the boiling point of water, without using a flame. Today's solar water heaters work on the same basic principle by transferring the sun's radiation with specially coated absorbers to heat air or water.
For instance, if you ever had the experience of your garden hose in the sun, you'll notice that it provides hot water. This is the same principle. However, we use an insulated box, we use copper to be able to heat the water to a higher temperature to which you'd ordinarily use within your home or your business.
You can tell if a building uses solar heat because the solar collector is either attached to the roof or nearby. Unlike early solar heaters, today's passive solar heating systems are much more effective because they circulate water through copper tubes inside a specially coated box. Most have no working parts and require only local water pressure and sunlight to work.
It's far less expensive to heat water with solar than any conventional fuel source. Number two is the concern about climate change. You don't need any fossil fuels which emit carbon to heat water.
Modern solar heaters start off as a plain roll of flat copper. The copper roll is first cut to the length of the tubes that will fit inside the solar collector. Then, the copper is put into a press where it is given its round shape. From there, a technician inserts the shaped copper into an automated welder. After checking that it is in precisely the right position, the welder combines an arc of electricity with an inert gas to create a flame that melts the copper and allows it to fuse together. Once the heat is removed, the metal begins to cool and solidify, creating a perfectly round, leak-proof tube. From there, the newly formed copper tube is taken to a stand where caps are welded onto either end. In this case, the 4-inch diameter tubes are then arranged in order on a rig called an absorber plate.